Toyota confirms next-generation battery technology and guarantees a 621-mile range by 2027 with more promises. And to make entry-level EVs inexpensive, an array of battery alternatives will be provided, some concentrating on performance and others on cost. Toyota has recently been under fire for the limited range of its EV cars in tests. However, the Japanese automaker may soon go from last to first. The company has announced that its next-generation battery technology will start showing up in production cars in 2026. In the beginning, we should expect a range of about 500 miles (805 kilometers) between top-ups, and later versions will almost quadruple that. Toyota has chosen to develop many battery types to fit various uses, similar to how it now produces combustion engines with a range of various specifications and power outputs. Other businesses that have made this decision include Ford and Tesla. There will be two at first: a performance battery for high-end vehicles that employs lithium-ion technology, and a popularization battery for entry-level EVs that uses lithium iron phosphate chemistry. According to Toyota, the performance battery will be the first to arrive and will go on sale in 2026. It will have a range of 497 miles (800 kilometers), a 10 to 80% charge time of 20 minutes or less, and will cost Toyota 20% less than the battery used in the BZ4X at that time. The cheaper LFP, which is scheduled to launch later in 2026 or potentially 2027, will raise cost savings to 40%, extend cruise range by 20%, but only to 373 miles or 600 kilometers, and have a 30-minute charge time from 0 to 80%. The bipolar technology that Toyota pioneered and validated with its nickel-metal hydride hybrid electric vehicle batteries is used to build the popularization battery, together with less expensive lithium iron phosphate as the core material. A high-performance lithium-ion battery, which will be available in 2027 to 2028, will cost 10% less than the first performance battery. Although it offers a range of over 612 miles, 1,001 kilometers, it requires the same 20 minutes to charge. However, that range can only be attained with a vehicle that is designed for slick airflow and little curb weight. In order to make additional advancements and expand the cruising range capabilities to over 1,000 kilometers when combined with improved aerodynamics and decreased vehicle weight, the high-performance battery combines the bipolar structure with lithium-ion chemistry and a high-nickel cathode. There's more to it than that, though. Toyota's first solid-state battery, which will also have a range of 621 miles but can be charged to 80% in just 10 minutes, will also be available in 2027 or 2028. A subsequent evolution will increase an EV's range to more than 746 miles, 1,200 kilometers, and eventually to as much as 932 miles, 1,500 kilometers. Toyota has made a technological advancement in its attempt to increase the longevity of lithium-ion solid-state batteries, a development that has long been regarded as having the potential to revolutionize BEVs. Because the electrolyte of Toyota solid-state batteries is solid, ions may travel more quickly through them, and they can withstand higher temperatures and voltages. Because of these characteristics, solid-state batteries can supply more power in a smaller package and can be charged and discharged quickly. Until now, the price was a predicted reduction in battery life. The business has shifted its focus to getting solid-state batteries into mass manufacturing as a result of Toyota's recent technological advances, which have surmounted this obstacle. The next generation of Toyota's BEVs are the company's main emphasis right now, even though solid-state was originally intended to be introduced on HEVs. In addition, Toyota is now working on a lithium-ion solid-state battery with improved specifications that will aim to have a 50% greater cruising range than the performance battery. Toyota is also striving to reduce the height of its vehicles overall and the thickness of its battery packs to increase passenger comfort inside and to improve aerodynamics, which will increase efficiency. According to the specifications, the battery in the present BZ4X measures 150 mm (5.9 inches) when its housing is included, but this will decrease to 120 mm (4.7 inches) for conventional cars and 100 mm (3.9 inches) for sports cars. All vehicles' ranges are significantly impacted by aerodynamics. Obviously, a growing amount of attention is being paid to lowering or optimizing CD, drag coefficient, ratings in the effort to increase the range of BEVs. Toyota takes this into account and goes one step further by focusing on CDA, CD multiplied by A, frontal area, which has a significantly greater impact on a vehicle's range capabilities due to the frontal area's multiplying effect. The height of the battery, which is generally stored under the car's floor, is at the center of Toyota's thinking. This may result in an overall rise in vehicle height, which will subsequently have a magnified influence on CDA and, as a result, on the performance of the vehicle's range. It follows that if the height of the battery can be decreased, the vehicle's overall height can also be decreased, and the CDA and overall range can all be improved. Toyota is therefore also developing battery technology that is ever flatter. As of right now, the BZ4X battery pack is about 150 mm high, including the casing. Toyota intends to lower the battery height in the future to 120 mm and even 100 mm in the case of high-performance sports cars when a low hip position is also preferred. Depending on how they are installed in the vehicle, these battery height improvements may have favorable effects on range, driving engagement, and packing. Meanwhile, let's dig deeper into the development of bipolar batteries and Toyota's exceptional success. With the introduction of bipolar batteries, an innovative technology that has the potential to revolutionize renewable energy systems and electric vehicles, the energy storage industry is undergoing a radical transformation. Toyota, a renowned automaker, is at the forefront of this innovation. Toyota has achieved a feat that has garnered the industry's attention, adopting a bipolar battery in their cars. From this further, we explore the idea of bipolar batteries, their benefits, and why Toyota's innovative approach signals a turning point in the search for effective and sustainable energy storage options. Contrary to the conventional monopolar battery architecture, bipolar batteries have different polarities. Bipolar batteries intelligently combine the cathode and anode materials into a single unit, organized around a metal part known as the current collector or bipolar plate. Unlike ordinary batteries that use separate cells connected by wires or tabs, the construction and performance of the battery are streamlined and improved thanks to this special layout that makes it possible to stack many cells together without the use of intercell connectors. Imagine a conventional battery as a set of distinct compartments, each holding a positive cathode and a negative anode electrode, similar to the individual bread slices in a sandwich. Each slice of the sandwich needs to be connected to the others using wires or tabs, much like intercell connectors in a standard battery, in order for the sandwich to function as a whole. Even while it works, this design can present certain difficulties and inefficiencies, especially when trying to increase the battery's capacity. Let's now explore the novel design of a bipolar battery with the groundbreaking sandwich. By combining positive and negative electrodes into a single layer and aligning them perfectly around a unique metal plate known as the current collector, which serves as the filling of our bipolar battery sandwich, we produce a new type of sandwich in place of using separate slices of bread. The filling, the current collector, in this new design acts as the electrical connector between each layer, similar to how a filling holds a sandwich together. The bread in this new arrangement is made up of both positive and negative electrodes in a single unit. We achieve a more efficient and compact battery structure since we don't need individual cables or connectors between the layers. We can build a tall and strong battery tower by stacking several layers on top of one another using the bipolar battery sandwich without having to worry about extra wires getting tangled up in the process. And so, do you think Toyota has a chance to defeat Tesla in this EV race? Share your thoughts in the comment box below. And if you've watched up to this point, thank you so much. For more videos about EVs, Toyota, Tesla, Ford, and the most recent auto news, please consider subscribing to Tech Addicts.